Hey 10th graders, welcome to my channel. So this channel's name is Student Simplifies, and today I'm gonna continue the trigonometry chapter. In this video, I'm going to solve trigonometric examples of this textbook. So make sure to watch till the end. Let us start the video now. Let us start with this example. So if tan A is equal to 3 by 4, then find the other trigonometric ratios of angle A. Given here, they have given that tan A is equal to 3 by 4. So, in the last video, in the last two videos, I discussed about all the trigonometric ratios and trigonometric identities, etc. If you did not watch that video, you're not going to get this one clearly. So go watch those two videos. So here they have given tan A is equal to 3 by 4. We know that tan theta is equal to opposite side by adjacent side. Here they have given angle A. So let us see the angle A. The opposite side of angle A is 3K. See, BC is the opposite side of angle A. So it is 3K. And the adjacent side of angle A is AB. So it is 4K. They have given. We have to put K in front of both of these ratios. So let opposite side is equal to BC, as I told you earlier, is equal to 3K, where K is any positive number. Okay, and adjacent side is equal to AB, is equal to 4K. So next we'll see. Yeah, here now we have in triangle ABC. Yeah, as I said you in the previous chapter how to apply the Pythagoras theorem of right angle. So AC square is equal to AB square plus BC square is equal to 3K. AB is equal to 3K. They have given in the question itself. So AB is equal to 3K whole square plus 4K whole square. BC is the opposite side of tan theta, tan A, opposite side, and it is adjacent side of tan A. So 3K whole square plus 4K whole square is equal to 25K whole square. What is the 3 whole square? Value of 3 whole square? It is 9, and about 4, it is 16. So 9 plus 16 equals 25K square. So AC is equal to, we have square here, over here. Wait, let me write here. AC square. We have sent this square to right side, so it is root over 25K square. So what is the value of root over 25? It is 5, and here for K, square and root get cancelled, so 5K is the hypotenuse of the tan A, of the given what do we say right angle. So 5K is the answer. So in the question also they have asked, show you, if tan A is equal to 3 by 4, then find the other trigonometric ratios of angle A. They have mentioned here, so we are finding the other ratios too. What are the other two ratios? It is sine and cos. So let us see here. Sine A. What is sine A? Opposite side by adjacent, not adjacent, hypotenuse. Opposite side by hypotenuse. Sine is opposite side by hypotenuse. Let me write here so you don't get confused. It is also can be written opposite side of A by hypotenuse of A. They have mentioned A here, so I have written A. Sin A is equal to 3k by 5k. So k get cancelled, so it is 3. The ratio is 3 by 5. Here k is any positive number. Here 3 by 5 is the ratio of sin A. Similarly with the cos A. What is cos A? Adjacent side by hypotenuse. So here adjacent side they have given 4k. So and also we have found that the hypotenuse is 5k. So 4k by 5k. The ratio is 4 by 5. So cos A is equal to 4 by 5. So hence the other ratios are these two. Since this, what do we say? Cosecant A is equal to 1 by sin A. That means reciprocal of cosecant theta is a reciprocal of sin A, and sin A is the reciprocal of, what do we say? Cosecant A is the reciprocal of sin A. So 5 by 3. Sin A is equal to 1 by cos A. In the earlier videos, I have discussed these all formulas and also identities. So you have to watch them for sure. But that means you have to clearly watch them. So sin A is equal to 1 by cos A is equal to 5 by 3. These are the ratios. So as I said you, cosecant A is a reciprocal of sin A. So 5 by 3. Here 3 by 5. In the second case, secant A is equal to 5 by 3. 5 by 4. Here cos A is equal to 4 by 3. The next one is cot A. So similarly, cot A is the reciprocal of tan A. So what tan A they have given in the question as 3 by 4. So here cot A is equal to 4 by 3. This is the first example. Let's move on to the second example. Let us see. So in the second question, let's see if angle A and angle P are acute angles such that uh, A is equal to sin A is equal to sin P, then prove that angle A is equal to angle P. They're saying that we have to prove that the angle A is equal to angle P. So they have mentioned that angle A and angle P are acute angle. So here these are acute angle over here, angle A and angle P. So let us move on to the problem. Given that sin A is equal to sin P. So what is sin A? What is the ratios? What are the ratios of them? So sin A is equal to opposite by hypotenuse. So here in the triangle ABC, let us see the opposite side of angle A and hypotenuse of angle A. So here opposite is BC, and hypotenuse is AC of angle A only. If it is C, we will get AB by BC. Since this is angle A, we are getting BC and AB. So not AB, AC. BC by AC. This is opposite and this is hypotenuse. Similarly with QR and PQ. Let us see. So the opposite side of angle P is a QR and hypotenuse of angle P is PQ. So QR by PQ. So then, as these are corresponding sides, so AB AC by ABC by AC is equal to QR by PQ. So we are assuming that these both are equals to K. This is our equation 1. So let us move on to the next step. So here but I'm using the Pythagoras theorem. Let me write. so that you won't get confused. See, how did we get this here? Here AC is the longest side, so AC is the hypotenuse. AC whole square is equal to AB whole square plus, and what here, AC, AB and BC whole square. So this is our Pythagoras theorem we have applied to this triangle. So let us do the further step. Mm, so here we have sent this AB square here. We have not sent is equal to send this AC square over here. No, what do we say? This BC square over here. So AC square minus BC square. Look here, we have not sent this AB square to this side. We have sent this BC square on the left side. So it becomes AC square minus BC square. So send this square over this side, so it will become root. So like that we got this equation here. AB is equal to root over AC square minus BC square. Similarly with the triangle PQR, we have got same like that. I want you to do that too, as I did here. So next step, we have assumed that, see Luca, I'll tell you. Yeah, let me be clear here. So I'll solve here. How did we get this k square over here? See, BC by AC. In the earlier case, sin A is equal to BC by AC. We have assumed that this is equal to K, and also this is equal to K. So let us equate this one, K. So further, BC is equal to K AC. Or simply we can send this BC also there by, like what would you say, AC ఇక్కడ నుంచి BCని కూడా ఇటు పంపించవచ్చు, ఎట్లన్నా చేయొచ్చు. So BC is equal to AC, KAC. So like that we got this K square. So here BC square is there. So if we apply here also, the place of in the place if we apply this in the place of BC, we'll get square 2. What is the value of BC? KAC, right? So whole square, because here square is there, we are applying here BC is equal to KAC. This square comes here, so K square AC square. As you can see here, it is this runs with this also, root over PQ square minus QR square. So root over PQ square minus K square PQ square, because QR by PQ is equal to K. I hope you won't get confused in this. So we have to take AC as common in this. Let me take AC square of AC square minus K square AC square. This is the given one. We got this one. So we have to take common. Here, what is common in this whole equation? Whole thing. AC is common. So AC into AC into AC square. We can take as 1 also, as you can see. We can take AC square also, because AC square is common here. Wait, let me do it once again. AC square of 1. AC square into 1, AC square minus K square. So AC square into K square is K square AC square. Are you clear? I hope you are clear here. So let me tell it once again. Here, don't look at this one. AC square, AC square, we have written as 1. AC square into 1 is equal to AC square. AC square into minus K square is equal to minus K square AC square. We have taken common here. So let us move on to the problem. Here, like I have told you here, this is also same. So here minus K square, 1 minus K square and 1 minus K square get cancelled. So remaining we have a root over AC square by root over PQ square. So square and root get cancelled. We have AC equals to AC by PQ. We have got this from this whole solving from equation 1. What is equation 1? We have assumed this one as equation 1. So AC by PQ. AB by PR is equal to AC by PQ. Here, look at here. AC by PQ is equal to AB by PR is equal to BC by QR. So then angle ABC is similar to triangle PQR. So triangle ABC is similar to triangle PQR. So if both the triangles are similar, then we can say that angle A is equal to angle P. So this is the example 2. Let us move on to the example 3. So this is the example 3. Let us read it out. Consider a triangle PQR, right angled at R, in which PQ is equal to 29 units and QR is equal to 21, and angle PQR is equal to theta. Then find the values of cos square theta plus sin square theta, and also cos square theta minus sin square theta. Okay, let us clarify the question. So this is right angle triangle. They have given that PQ is equal to 29 units and QR, this is QR, is equal to 21 units, and angle PQR as theta. This is the given. So they are saying to find cos square theta plus sin square theta and cos square theta minus sin square theta. So let us find that out. In triangle PQR, we are using Pythagoras theorem here. Let me just solve it here so that you won't get confused. So here let us use the Pythagoras theorem. So the longest side is PQ. PQ whole square is equal to PR whole square plus QR whole square. So we are sending this QR on the left side. So PQ whole square minus QR whole square PR. We are sending this square to this side. So PR is equal to root over PQ whole square minus QR whole square. Here also we have that PR is equal to root over PQ whole square minus QR whole square is equal to root over 29 whole square minus 21 whole square. They have given that 29 and 21. We just have to substitute the given values in these two values. So let us do the next one. So we have root over 400 here. What is the value of root over 400? It is 20 units. And 20 units. We got this adjacent side too. What is that? 20. This is adjacent side. To find adjacent side, we have used this Pythagoras theorem. Or simply we can use another method also by taking sine. Since we have there is no value of theta here, so we are using Pythagoras theorem. If we have the value of sine, if we have the value of theta over here, we can simply apply those ratios like sine theta, cos theta, like that. You will know that method in further examples. So let us do this one. Root over pq square minus qr square. We have got this 400 here. So since we got that 20 units as adjacent, let us do more. So what is sine theta? Sine theta is equal to opposite by hypotenuse square. Opposite by adjacent. Wait, what? Okay. Sine theta PR. Yeah, okay, sorry. Opposite by hypotenuse. I just got confused here. So opposite side of what is the opposite side of sine theta? Here theta is the angle. So theta, here's the angle theta here, q. So what is opposite to theta? This is opposite to theta. So this is opposite side. This is not adjacent. If we take in the Pythagoras theorem, it is adjacent side because it is down. But here theta is given. So for theta, it is the opposite side. So PR is the opposite side of theta. And what is the hypotenuse? Hypotenuse is PQ. So 29. So 20 by 29 is the sine theta, and cos theta is 21 by 29. What is cos theta? Adjacent by hypotenuse. Adjacent. What is the adjacent of tan theta is 21, and hypotenuse is 29, as you know. So adjacent by hypotenuse is the 1. What is the adjacent side? It is 21 and hypotenuse is 29. So 21 by 29. Cos square theta, cos square theta plus sine square theta. Cos square theta is 21 by 29 whole square plus 20 by 29 whole square is equal to what is the value of 21 whole square is 441, and 20 is 440. What is we have taken all this also, so it is a 841. Like this we got 1. So here, as you can see, it is clear. And also with this too, cos square minus we have did here. So 41 and 840. So this is the example 3. So after example 3, we have exercise 1 here. I want you to do this all problems. If you can't, you have the material also. Or in the school, your teachers are also there to say. I am here to explain you the extra questions and do this problems and also examples. But you have to do this exercises of the test book. Hope you won't feel anything. I'm saying this because you have material of this one, of of solutions of these questions, so there's no problem to solve them. I'm here to explain the extra questions and examples, also, and also do these problems. Let us move on to the next example, which is 4. So this is the example 4. Let us read it out. So in triangle ABC, right angle, which is 90 degrees, is at B. AB is equal to 5 centimeters, and angle ACB is 30 degrees. Determine the lengths of sides BC and AC. They are saying to find AC and BC. What they have given is that right angle is at right angle, which is 90 degrees, is at B, and AB is equal to 5 centimeters, and angle ACB, which is angle C, is 30 degrees. So here they have given AB is equal to 5 centimeters and the triangle ACB is equal to 30 degrees. To find the length of side BC, we will choose the trigonometric ratio involving BC and the given side AB, since BC is side adjacent to angle C and AB is the side opposite to angle C. So here they are saying that we have uh, uh, we have to find the angle BC. So to find BC, we have to take AB2. As I said you before, there is an other method to solve that type of questions as example 3 and 2. So let us clarify this to you. Let me clarify this to you. AB and BC. To find the BC, we have to take AB, the side AB. So, what is the relation of AB and BC? The relation of AB and BC is a opposite side of angle C by adjacent of angle C. So, opposite by adjacent, which is tan theta. So, tan C. Why did they take C here? Because the opposite side of angle C is AB and adjacent is BC. So AB by BC. We have took this tan ratio here, tan C. So let us see how should we apply that. Phi by BC. How did we get phi here? Because they have given that AB is equal to phi. So to find BC, we have taken that AB there. So tan theta, here they have given the value of angle C as 30. So tan C is equal to tan 30. So phi by BC is equal to tan 30. What is the value of tan 30? In the previous two videos, I have uploaded them. You can find the ratios. Like you have to rectify them. You have to keep that in your mind. Those all values of the whole ratio: sine theta, cos theta, tan theta, cot theta, secant theta, and also cosecant theta. You have to keep them in mind. So see here, tan 30 value. Here you can see the table. Where is tan A 30? The value of tan 30 is 1 by root 3. So here tan 30 is equal to 1 by root 3. So phi by BC is equal to 1 by root 3. So we have the three values. So we can find BC easily. So to find BC, we are cross multiplying BC into 1 and phi into root 3. BC is equal to phi root 3. Like this we have to do. Did you understand that why did we took AB here? This is the reason for it. If we take that value of AB there, we can find the BC value easily. If we have the value of theta 2 and also the value of one side, we can measure the other two sides easily. So here we got BC as a phi root 3. Let me write here phi root 3. BC is equal to phi root 3. And let us find this one side. We can take this ratio or this ratio. Let us take in this question they have taken sine 30. So uh, they have taken opposite by hypotenuse. We can take this BC by AC2. Let us take. It is not there in the question, so let me take that. So what is BC? by AC. A BC is the BC is the adjacent side, and AC is the hypotenuse. So, what is the adjacent by hypotenuse relation? It is cos C. I have taken C here. You know that. So, what is the value of cos 30? Let us see here. Cos 30 is root 3 by 2. So, what is adjacent? Adjacent is 5 root 3 by AC. We have to find the AC. So, we are writing this AC here is equal to, what is that? Root 3 by 2. So, let us cross multiply it. So, we can get AC root 3 is equal to 5 twos are 10 root 3. So we are sending this root 3 on right side. So 10 root 3 by 3. We have to rationalize it. What is the meaning of rationalizing? We have to multiply the same on this 2, like C by root 3 with opposite sign. Since it is root 3, we don't need to apply those two. So we have to do this in further problems too. You have to know this rationalizing method. So let us do that. So 10 root 3. Root 3 into root 3. What is that? Wait, let me just see. Okay. Okay. 10 root 3 into root 3. What is root 3 into root 3? It is, wait. Not comfortable here. Let us do here. So 10 root 3 into root 3 by root 3 whole square. This is also whole square, so square root cancel. So if we take it as this 10 root 3 whole square, so square root get cancelled by 3. So 10 threes are 30. 30 by 3. 3 ones are 3 tens are. So we got here AC is equal to 10. So AC is equal to 10 centimeters. You have to mention the units too. It is very important. So here AC is equal to 10, as you can see. We can use this both ratios. There is no particular thing that you have to take. You can take both. So let us move on to the next example, which is example 5. So here a chord of a circle of radius 6 centimeters is making an angle 60 degrees at center. Find the length of the chord. This is chord. This is chord. Over here, they're saying to find the length of this one. So by using, they have given that the OA is equal to OB is equal to 6 centimeters. This OA and OB is equal to 6 centimeters. And angle OAB is 60 degrees. Let me mention here 60 degrees. If we do half like this, so here we have right angle triangle. See, this is a OAB. They have given this 2 as 6 centimeters, and this whole angle is 60 degrees. If we take one triangle here, the half of 60 meters, the 60 degrees is a 30. So we get 30 here. The half of 60 degrees is 30 here. If we take half of this whole triangle, like a right angle triangle, we will get 30 degrees. We can assume this side over here as a C, and this is O, as you can see. So let us find the length like this. So here, we can take, they have given 6 centimeters over here. So we have, this is the angle they have given, 30. So what we can take here? Hypotenuse and opposite relation, right? So let me clarify. Let me draw this clearly. See, I have drawn it clearly here. So here OC and OA, 6 centimeters. They have given OA as 6 centimeter in the given question. So 30 degrees we have got by 60. This is the half of 60 degrees. So it is 30 degrees. Half of 60 degrees is 30 degrees. Like that we got 30 degrees. So 6 centimeters. What relation should we take here? Here we have 6 centimeters. With that we can find the second angle too. This. Or we can simply find this one. Let us find this one. So if we take this one, there is no use. So we have to take the down one. Since we have to find the length of this one, we are taking this down one. So 6 centimeters. What is this? This is the angle which they have given. So what is the opposite of this angle O? The opposite of this angle O is AC. Let us write here AC and A AO. Of this is the hypotenuse of angle O. So by AO. What is AC by AO? Which is opposite by hypotenuse, which is sine theta. Okay, then AC is not given by 6 centimeters, is equal to sine theta. Sine theta is sine 30, sine O, like we can say sine 30. So here we have to do the cross multiplication. What is, wait, not now. What is the value of sine 30? Move on to this one. Sine 30 is equal to 1 by 2. AC by 6 is equal to 1 by 2. So 2AC is equal to 6. We have to send this over there. AC is equal to 6 by 2, which is nothing but AC is equal to 3. Here BC, here AC is equal to 3. If we do this similarly with BC, we can get BC is equal to 3 2. As you can see this, BC by OB. I have taken this triangle first, but they have taken this triangle first. We can take this and do the same too. So let us see with this triangle too, COA. They have taken sine theta because it is opposite and it is hypotenuse. So BC by 6, 1 by 2, cross multiplication. Then we get BC is equal to 3 2. So we have AC and BC too. AC and BC. If we add these two, we can get 6 centimeter. Or we can, if we find only the one value, we can double it, because we have taken the half of 30 degrees. We have to multiply. See, it is 3. We have divided it into both equal parts. AC is equal to CB. So 2 into AC means nothing but 6 centimeters, right? AC is equal to BC. So we can take AC 2 times, which can give us 6 centimeters. This hole is 6 centimeters. The length of the cord is 6 centimeters. Or we can find this 2, which is lengthy. You don't have to do that. You can simply multiply it by 2. If we got one angle, simply multiply it by 2. Then we can get the length of the cord, which is 6 centimeters. Let us move on to the next examples. Before moving on to the next examples, we have to make sure that to uh, we we have read the whole, what do we say, textbook. You have to read this simple details, like over this whole paragraph over here. They can ask in objectives. It is my suggestion it is my suggestion that you have to read that whole textbook. Only reading, not solving. You have to solve. After solving, you have to read full textbook.